Hello, everyone, and I'd like to welcome you to the Data Center Frontier Show, where we tell the story of the data center industry. I'd like to thank you for tuning in. Today, we're going to have a conversation about data center cooling, a subject that's near and dear to the hearts of most of our audience. And to share his insights, we have Kevin Facinelli, the president of Data Center Solutions at Nortek Air Solutions. So, Kevin, welcome to the show.
Well, thanks, Rich, and I appreciate the opportunity to share with you as well as Data Center Frontier community some of the knowledge and experience I have in the industry. I currently, as you stated, am president of the data center cooling business at Nortek. That encompasses the responsibilities for design, manufacturing of systems and solutions that are deployed within smaller to mid to even hyperscale data centers.
So Kevin, data center cooling is one of the topics that's always near and dear to the hearts of our audience and our readers in the data center industry. One of the things I wanted to ask about today was the scale of data centers and data center campuses. We see, your traditional enterprise data center might be a couple of megawatts, but now we're seeing facilities that are as, up to 80 or 100 megawatts or more. What are you seeing there, and how does the growing scale of these data centers impact the way that they think about cooling?
Yeah, it's really interesting, Rich. You're absolutely correct. We're seeing definitely larger data centers out there in the industry today. 30 megawatt data center a couple years ago was a pretty large data center. Switch has deployed a 130 megawatt data center in Reno on 2,000 acres of land with, I think the finished build out is 7.2 million square feet of floor space. So pretty amazing to see, and that's the co-location. We're also seeing that in the hyperscale market, where larger hyperscalers are pushing above 100 megawatts all the way close to 200 megawatts in buildings. There's actually one of the leading social media companies right now that's building a 180 megawatt data center in Singapore, all on 12 acres of land. And it'll be a multi-story building. It's 11 stories, very significant development. But the other thing we're seeing is things are getting smaller at the same time. So we're seeing the emergence of edge computing or edge data centers and micro data centers. So as things are getting bigger, they're also getting smaller at the same time, depending upon what types of services you're presenting to your customers out there and what types of things you're delivering in terms of application and your ability to reduce latency and provide very strong services.
So you mentioned Singapore. One of the other sort of interesting trends in data center cooling is that geography really matters. And what are you seeing in terms of the way that data center providers approach the way they're using cooling technologies in different parts of the world?
Yeah, data centers are going up in just about every different geographical location across the globe. So we're seeing quite a significant amount of data center activity in Asia, where it's a very hot and humid climate. In those situations, traditionally people have been utilizing direct expansion and liquid chiller-based cooling tower refrigeration for cooling the data center itself. But we also have a technology that we've come out with that we're deploying in that same region that is an indirect evaporative technology. I think it'll be one of the first ever deployed in that area itself.
So tell us a little bit more about that. How is Nortek approaching that challenge, and tell us a little bit about the
Yeah, we this past year came out with a brand new technology, which we refer to as StatePoint technology. At the core, it's a microporous membrane heat exchanger. And what we do is we have the ability to run this package unit in 3 different modes. So if the environment is cool, we can run in an economizer mode where we're taking air from the outside across a cooling coil and then that cooling that water and then moving that down into the data center and distributing that, using a fan wall or a CD or a crawl or other type of distribution unit inside the data center. The other mode is when it's a little bit warmer, we can go into an adiabatic mode. And this is where the actual membrane exchanger cools the air using very low levels of water to precondition the air across that coil, again, generating cool water like a chiller would, and distributing that into the building. And the last mode is what's called the super evaporative mode. And in that mode, we're actually taking the heat or the heat coming back from the data center through the cooling coil, and then we're also pushing through evaporation in terms of air to cool that coil and water evaporation to cool the water stream itself, and mixing that back together and moving that back into the building. That's probably when we're talking about hot and humid climates. That's the mode that you're going to tend to see this unit operate in a Singapore or Asia environment.
Does that have application in other geographies as well, or is it primarily something that works well in the warm climates?
Absolutely, it can work in just about any geography. When we have the ability to economize and bring in fresh air, the nice thing about that, in a northern climate, you can really reduce down consumption of water, as well as reach very, very low PUE levels. We have designs that can get to a 1.1 or even maybe a little bit lower than that on a PUE. When you have a 4-season environment where you may have a cool season and a hot season, because you can run it in different modes, you then go into an evaporation mode where during the summer, it'll automatically switch over to that evaporation cycle and produce chilled water during that condition as well. So the unit itself has DVC controls in it, so it automatically will move between the different modes to optimize use of water as well as energy when providing cooling to the data center.
So one of the things you mentioned was the use of multi-story data centers. This is a trend we're seeing in a number of markets where real estate either isn't available in large footprints, or where the specifics of data center geography for interconnection purposes are very important. So we tend to see people trying to make the most of the real estate and build 3- and 4-story buildings. As you mentioned, in some urban areas, you'll see much taller buildings. I gather this must have implications for how you design the infrastructure and the types of decisions you make there. Tell me a little bit, in your experience, how multi-tenant data centers impact the cooling decisions.
Yeah, I think the vast majority of large hyperscale data centers today are single-story on a mass amount of land, and they spread out across acres and acres of land. But you're right, what we're finding is the need to have data center technology in urban environments, as well as land constrained areas. So when you move from a single story cooling technology to have to cool multi-story, you have to find a place to put your cooling equipment itself. Our product, StatePoint, is designed to go on a mezzanine on each one of the floors, and then deliver that chilled water to a fan coil wall unit inside the data hall itself. So we actually can put on top of each layer or each floor a unit delivering cold water to that separate floor. And then that's exhaust up a chimney through the building itself. The nice thing about an indirect evaporative cooling system is the air is very buoyant. So, a cooling tower, sometimes you'll have a plume that comes off a cooling tower and it just drops down and you're going to pull it back into the building. What happens when you're using an indirect evaporative cooling or a StatePoint technology is the ability for that to have very buoyant air and actually move upwards into the atmosphere away from the building and not having any recirculation of that air.
So one of the trends that we've been tracking for a lot of years at Data Center Frontier and in some of our earlier writing positions in the data center industry, I've been doing this for 20 years now. But one of the things we've always looked at is density. It's always a topic of discussion that ultimately liquid cooling would be coming in and would see greater adoption. I think the first presentation I saw about the imminent arrival of liquid cooling was at a 7x24 event in 2002, where the vendors were all saying that this level of density was inevitable. But in recent years, we have seen server densities, cabinet densities trending upward, and partly because of some of the hardware that's come into the market for artificial intelligence. So I'm curious about your take about what you're seeing in terms of data center density, what those trends look like, and how that might impact the way that people approach cooling.
Yeah, absolutely. We have a full line of high performance computing products, and those are designed to take and distribute water to the rack or to a cold plate or to a chip. The vast majority of our customers are supercomputer customers today, where they're putting a series of racks in very high density processing to do calculations and computations that really wouldn't be able to be done in a different geometry than what they have in the supercomputers today. But you're right, what we're also seeing is the emergence of GPU technology and other technologies that have a heat density that's much higher than what we've seen in the past. And there's going to be a tipping point there where air cooling, just based upon its ability to move air through a unit and the aspect ratio of kind of moving that air and getting the heat out, is going to be more and more difficult. I think in general, though, what we're seeing is the large data center providers and hyperscalers out there have just an enormous amount of servers they're deploying, and they're not as computational, strapped in what they're doing in the presentation of their services. But as that technology keeps on pushing the processor heat up, I think we are going to see more application. Most recently, you're seeing Google came out with their own designed system for AI application and deep learning. Those are the types of applications. But you're right, I've been in the industry since the 1990s, and every year we talk about water cooling, and it seems like the processor guys figure out a way to take more power away from the chip and still increase its performance. The Moore's law philosophy.
Yeah, there also are now a group of startups in the hardware space, which used to be a hard place to run a venture-backed startup. But I think one of the things that artificial intelligence has done is boost the demand for really powerful specialized chips that, because they're really focused on one use case and really cranking up the power, create some different cooling challenges. I mean, Bitcoin is one example of how people using application specific hardware, but there seems to be more of that coming into the data center. But right now, what we generally hear is hyperscale folks, maybe 10 to 15 kilowatts per rack as a max. Is that a range that makes sense to you? How do you in your work with HPC, what are the kind of densities that you see and have to solve?
Yeah. Our CDU systems, we have a 1200 and what's called a CDU 6 that can produce a substantial amount of cooling that gets distributed to the rack itself. The 1200, has the ability to run multiple racks of equipment off of one CDU versus a 1-to-1 ratio. But there definitely is a lot of activity, even in the supercomputer space, where we all thought maybe that was a dead technology. The things they're able to do today with, working on the COVID problem is a good example. They're using supercomputer technology there to work on a potential immunization solution for COVID. There's just a lot of difficult problems that density of computer is required really to be productive and get to a solution in a reasonable period of time.
So you mentioned COVID-19, which of course is sort of front and center in how most people are thinking about their businesses and trying to figure out, how to.
Wish we weren't.
Yeah, well,
but I agree with you.
Yeah, so it's a big sort of strategic question for a lot of folks. The data center industry, I think, has done a pretty strong job in terms of handling the additional capacity requirements that have cropped up from cloud providers and online services, as just about everything has shifted to a digital online format. It's education, healthcare, government, everybody working from home everywhere.
Absolutely, it's amazing how much traffic. If you look at some of the numbers since January or February, when really the first cases started to emerge in North America, some applications are up 40-50% in utilization. I think the Zoom application we're on today is 30 to 40%. Microsoft Teams. It was interesting. The only application I saw that was down was ESPN's site, because there's no sports right now. So I was going out there and checking out, sports scores. So, but in general, most of the applications out there are seeing levels of traffic that they've never seen before.
So one of the questions that we've been looking at as we kind of work our way through to the evolving state of whatever the new normal is what are the sort of implications of COVID and how it is changing the way folks do business, with everything from, staffing, the distributed workforce, which then raises questions about the real estate holdings. As you look at some of the data center and the sort of digital transformation issues going forward, what are your thoughts in terms of what might be changing, what might stay the same? What's your sense of what the new challenges will be as we sort of navigate the next steps?
I think we're over that tipping point of it's okay to work from home. I think we figured out that we will survive, and in general, most of my team has shown a greater degree of efficiency because they're not having to travel to work, all the interruptions. We're using Microsoft Teams and the tools very effectively. Before that, I maybe got onto a Teams meeting once a week. Now I'm on a Teams meeting, I think, 4 to 5 times a day, working with team members. The other thing is there's a lot of companies out there that are making interesting announcements about their work from home policies and not bringing back workers to their campuses, some very large organizations. I think the downside of that really has to do with your ability to, if you're coming in as a new employee and you haven't been with an organization and you don't know the dynamics and the people, it's going to be a little bit tough to kind of learn the lay of the land via, not having that interpersonal time with some folks and interaction. But in general, I think we're going to see more pressure on commercial real estate, people coming back to that, and that just opens up opportunities. When we talk about those places where edge computing or small data centers could be provided in close proximity to their customer base and reduce the latency and do some compute, I'm hearing that commercial real estate is being looked at very closely right now by a number of organizations. And in terms of potentially redeploying that real estate that had been general office space use.
So that raises some interesting questions because, one of the things about data center real estate is it is specialized. There's lots of equipment. When we think about maybe how it could be more distributed and sort of edge use cases that might use some of this space that maybe corporations aren't using anymore. What does that look like, and how might that transition take place? And of course, because this is your wheelhouse, you know, what sort of cooling challenges does that create?
Well, obviously you have a pre-built space. It's not a greenfield where you're making
Right.
and designing your space for your application and cooling solution. So you got to really retrofit or make things work into that space. In terms of cooling, I think the densities are going to be lower than what we would see in maybe the hyperscaler, or the amount of compute obviously will be much less in that space. In terms of cooling, I think you're going to look at ways to bring in cooling through a fan coil wall or a crawl unit into the space. That could be facilitated through, like I said, an indirect cooling technology like we have. It could be a chiller, or it could be a water chiller or an air-cooled chiller. But reconditioning the space, it's not as intuitive. I think there's going to have to be some thought if you get beyond a certain level of computing in that space. Most areas you could probably afford to do 5 to 10 racks. If you're talking about, you know, 50 racks, that's just a different density and a different amount of cooling, and redeploying that space. There's some people out there right now that I know are working that problem right now and looking at different commercial real estate opportunities and developing solutions. And there's a vast array of, you know, consultants that I'm sure are part of your community out there that are working, you know, those problems.
So they might be looking at space that, you know, where a company used to have X amount of office space, but because they're only going to have at most maybe half their employees there, everybody's, you know, 6 feet apart and such, and so then they might like have you know, space that then they would like sublease. Are those the kind of opportunities you're talking about, or?
Yeah, I think you're going to see people vacate commercial real estate. I'm not saying it's going to be overnight, but I think maybe some goodness that comes out of this situation is people really start to understand how to effectively utilize these tools that we've had on our desktops. And we've hit critical mass that the availability to get to someone on that same tool is there, versus, you know, I might get interested in using one of these apps, but there isn't anyone on the other side that has the app or is in the mode to really have to use the app. Now, you know, like I said, in our organization, we have a vast amount of people other than our manufacturing sites that are working from home very efficiently and very effectively. You know?
Yeah, I suspect the travel budgets are going to get a hard look and be viewed very differently in the absence of this. And I've heard some folks, you know, like, I don't know about you, but myself, I used to go to a lot of conferences, and, you know, the travel time going back and forth, the day before, the day after, you know, I think some folks are see that as an interesting sort of trade-off with what's happened.
Well, I think the other thing, working from home, I am tending to work probably 20, 30 to 30% longer hours every day. You know, there's the break for lunch or a few interruptions, but in general, I think after the first couple of weeks, you really figure out how to do it and be effective at it. And people know you're at home. You can't get, I'm on an airplane or I'm traveling. They know you're there, so they can get a hold of you. So we're tending to work much longer hours.
We always like to, one of our goals at Data Center Frontier is always to think about what comes next, what's out on the horizon for the data center industry. In terms of cooling, what do you find interesting about, you know, what things are going to look like going forward? What's intriguing to you on that front?
Yeah, I think with the size of the data centers getting to the point where, I mean, hyperscale is it's now, you know, super hyperscale. That probably the most prevalent technology that's out there and deployed today would be a direct evaporative technology, but we're seeing a lot of hyperscalers moving over to an indirect evaporative technology. We are seeing people still using DX liquid cooled chillers for trim cooling applications. We're also seeing the push to have higher temperatures within the data center. So I know if you go back 10 years, we were at W1, which was 17 degrees C, which is about, I don't know, max 65 degrees C, I think it is. And now we're seeing a lot of W2 and W3. So now we're pushing with W3, I think we're up to about 34 degrees C in the data centers. W2 is very common, which means the max temperature is 80 degrees Fahrenheit. And then a W3, like I said, at 90 degrees. We have a lot of most of the hyperscalers are pushing up to the W3 right now.
Right.
Because what that does is, they're using less energy. They're using less natural resources. And that's another emerging issue is as we're building all these data centers, they require resources to make them work. And
Right.
typically in this industry, the two resources we see are water and energy. And water, where things maybe are easy in terms of cooling, there may be a really difficult situation in availability of water. And you really have to project that over a long period of time. So if we went back 5 years, you remember we had the droughts and all the forest fires. So when the forest fires were happening and you were using direct evaporative systems, everyone was like, oh, we're pulling smoke into computer rooms, and smoke and pollution and that sort of thing do not work well with electronics. It just, and electronics in, let's say, a humid environment, non-condensing, but a humid environment. So people are really thinking about the business as something that they're going to own or operate over a long period of time. And what are the considerations? So your natural resources become one, your availability to power and large amounts of power at reasonable costs, your availability to, I think fiber connections is not as big a deal as it was maybe 5 years ago, because there's just quite a bit more fiber that's been laid down into the, either across the ocean or, across the continental, land masses.
It always seems like the resources that are the most important in terms of planning and site selection is the ones that are going to be scarce or are going to take a long time to provision. And so
I tell you what, I was reading a really interesting report. So Google puts out, just the general public, their environmental report every year.
Right.
So if you look at where they were, I believe in 16, they were using 2.5 billion gallons of water as Google, both office and data center. 2019, they're at 4.1 billion gallons of water. So it's the one thing it's really challenging as you grow the data centers and you're using liquid and direct evaporative cooling, you're using water. So it's definitely becoming a much more emergent issue with data center, design and sustainability.
Yeah, and it seems that a lot of local governments are much more tuned into the fact that that much as they love the economic development potential of data centers, that there are resource issues that come along with that territory. And those were discussions that maybe you didn't see in the same way, 5 or 6 years ago.
Well, I mean, 5 or 6 years ago, you remember Lake Powell was at an all-time low, and people weren't, alternating days on if they could water their lawns or not water their lawns. So it's not that, it's about the additive effect on top of what people are normally using. People use a lot of water, but now you put another, very highly water-intensive resource into a location, and you start to think about availability of that resource or long-term availability if I'm pulling down water tables. Yeah, it's definitely something that we're talking to people, and people are asking questions about that that issue and that problem, how to solve that.
Yeah. Well, listen, Kevin, I really appreciate you taking the time to spend this time with us on the Data Center Frontier Show and share your insights and your expertise with our readers. If people are interested in connecting with you or learning more about Nortek, where can they go?
Yeah, www. Nortek, nortekair.com. And on that, there is information on our data center products. We'll be coming out with a new website here fairly shortly. And with that, you can, I think there's also some white papers available, and there's a white paper even on Data Frontier or Data Center Frontier on kind of the StatePoint solution. There's a lot that goes into it. So it's hard to explain in a short bit of time, but if people are interested in more.
So the perfect topic for a white paper that people can sit with.
Yeah, sit around, and if they have questions, definitely contact us.
Well, we'll certainly include some links to all that in our show notes and our story accompanying the broadcast on Data Center Frontier. So Kevin, thank you for taking the time to speak with us.
Yep.
And I'd like to thank our audience for tuning in. As always, we love talking about data centers, and please visit our website at datacenterfrontier.com and subscribe to the Data Center Frontier Show on Apple Podcasts or wherever you get your quality podcasts. And until next time, this is Rich Miller signing off for the Data Center Frontier Show, where we tell the story of the data center industry one podcast at a time. Thanks for listening, folks.